Is that agreed, Sherry?
Yeah, absolutely. Let's kick this thing
Great,
off.
let's
I know some people may
go.
be dialing in a few minutes late if they got held up in a meeting or something like that, but they can jump in and catch right up.
Great. So I'm in charge of the slides. So I'm just going to start by giving everyone a bit of a background. I mean, sustainability is obviously, we know, quite an important issue at the moment. And Jonathan Rowley brought us all together. We all knew each other, but gave us an extra reason to come together and organise this event to try and capture some sense of what's happening around sustainability in AM and explore some of the ways in which AM could help us create more sustainable futures. Just to give you a bit of background, but also to welcome you and thank you for coming. Sherry and I sat down and thought about how we wanted to approach this as it's such a big topic. And we've decided to split it into a couple of days, and we wanted to look across the whole value chain, essentially, of the processes of manufacturing and how AM can fit into that. So today we're going to talk about design and materials, and we have 3 sets of speakers for design and 3 for materials. And Sherry will introduce each of those before each of those sections. And day 2 is on the 19th of June, and that will cover spare and legacy parts, and then also think about the whole value chain and AM's contribution to that. We wanted to start the conversation today very much as a conversation, and what we've built into today's event is plenty of opportunities for you to contribute through the chat, to ask questions. I particularly don't mind being interrupted at all if you have a burning question or issue. We've left time after each speaker as well for you to ask questions. So we are hoping to learn from you as much as we hope we're going to give some thinking points for you. We're aware probably that there's people on the call that have probably got different experiences, right from starting to think about sustainability right through those who are actually using AM for sustainability in a variety of different ways. So next, Sherry and I, rather than me speak about the academic background, I'm a professor of management at the University of Bristol Business School. I lead a team of interdisciplinary researchers from geography to supply chain management to engineering, computer science, all interested in digital technologies and their role in sustainable and resilient supply chains. I didn't want to bombard you and just talk at you for half the time, and neither did Sherry. So we've spent some time thinking about how we could do that in a more conversational way. So we're sharing this presentation, and we're going to interrupt each other occasionally, but we've already pre-agreed that's okay. And talk through some of the bigger conceptual and then practical issues. Sherry, I'm going to pause here and allow you to introduce yourself quickly before we go to the next slide.
Yeah, hey, really glad to be here. Really glad to be working with this group of people and putting this event together. I'm Sherry Monroe. I'm the executive director of the Additive Manufacturer Green Trade Association. It's kind of a mouthful, so the AMGTA. Several of the speakers that we'll have over these couple days are with organizations that are members of the AMGTA. And we are an international trade association focused on additive manufacturing and sustainability, so environmental benefits of additive and understanding that not only through the production and the production of materials, but also through the supply chain implications and really from a holistic business perspective, really understanding the environmental benefits of additive. So that's sort of the direction we're coming at this from. And really looking forward to the speakers talking about this from a variety of perspectives, as Jennifer said, coming at this from different experiences. And I think we're going to have a really great couple of days of conversation. So, and as Jennifer said, please, definitely while we're talking, I don't want to speak for the other speakers, but I know while we're talking, if you have questions or comments, just jump right in. We really want this to be very conversational and interactive. So yeah, chime in whether you want to type in a chat message or pop up, and say something. Yeah, join right in.
Thank you, Sherry. So our intentions are clear about waking everyone up and getting them engaged. So we'd like to start by asking you to think through what you think sustainability is. I'll come on to talk about some of the ways in which academia understands that, which are very context specific, but then also think about what the term means in relation to you in your role or business. So you can take a couple of minutes to think about that. And if you could then put those in the chat, that would enable us, or feel free to vocally articulate this. It's rare, but some people like to, and we encourage that. Okay, so Patrick says reducing energy consumption. Stalin says sustainable world around circular economies. I'll come on to that, so thank you for setting that up.
Yeah, absolutely.
Siva Priya, utilizing resources optimally. Okay, optimal, I like that. Lowering the footprint, great. By having the two questions, I think we're quite aware that sometimes you can have your own idea of what sustainability is, but that might have to adapt according to what your organisation thinks sustainability is. So that might be something that comes out of these conversations we're having, is how you can mediate between the two. Richard Cooper, not using natural resources, meeting the needs of today while considering the future. Understanding beyond the environment. Okay, that also sets something out. Jonathan, speaking to design, we are working the design for AM network, designing things to last and evolve, doing business without impacting the environment. Steve, sustainability is reducing waste through processes, driving to net zero, recycle waste, repair and reuse. Sounds very circular, Steve.
Alan's got a good point here. Sustainability in the business sense as remaining in business. Yeah.
It's as if you'd seen the slide, but you haven't, Alan. That's brilliant. Luke has quoted the UN definition of sustainability. Meeting the needs of the present without compromising the ability of future generations to meet their own needs.
Yeah, these are all really great.
Yeah.
And they're all, all overlapping, but not the same. Yep. And looking at it from a variety of perspectives, which I think is really important. Yeah, for sure.
Excellent. So I think that's a really good overview. Thank you to those who contributed. What is sustainability? I mean, we could talk about this for hours. I think it can vary. I think that there's issues around this term. It can feel like a catch-all sometimes. It can feel like a buzzword. I think that every corporation is duty-bound to address it and do it, and those that do it in a variety of different ways. For me, coming at this from an academic perspective and what I see when it translates into my engagement with the AM sector is thinking about business sustainability and environmental sustainability. And I don't think these two are separate. I think that they are related, but I highlight it because I think there is a role for thinking about how businesses can become more sustainable in a changing world, in an increasingly challenging world. So here we can think about resilience, around security, how the business sees its longer term future, and sometimes even its capability to stay open and to survive the coming year. Environmental sustainability might seem a bit more long-term, but is actually about reducing the impact of the firm on its environment. So that can range from net zero. We hear many firms setting and trying to achieve goals around net zero by 2030, for example. And some of this is obviously brought on by regulatory demands and from government demands. I've mentioned circularity here because this is one of the ways in which we talk about sustainability. I see a certain problem around the use of the term sustainability and circularity. I think they're different. I think you can be sustainable without being circular, but circularity can often be a route to sustainability, particularly as it's thinking about the flow of resources within a firm or within a system. I just wanted to make that point really, because I think that again, circularity can be something of a buzzword that can be used without fully thinking through what that means. I suspect and I hope that one of the things that might come out of today is that by using AM, we might find ways in which environmental sustainability can be achieved, but that also has positive outcomes for business sustainability. And I think we're probably wise to think about the two sitting alongside each other and how they can help each other. Sherry and I, and in a way our conversation is mimicking the very great chats we've had as we come to get to know each other about our different perspectives and the conversations we had. And we were thinking about these events and thinking about who you, the audience, might be and how you might be thinking about sustainability. And we wondered what the level of focus might be. And I think both these things could be happening. And it could be that you're thinking about how to make your firm more sustainable. So is it about your impact on the environment? Or is it actually about how your firm can offer services to use AM for sustainability to help other firms and other sectors? And again, I think these two can sit alongside each other, but it might depend on your role or it might depend on your interest in sustainability about where you think your attitude is, what your level of focus is. I think that creates some challenges for either scenario, and this might be something that comes out of what we hear from our excellent speakers over the next couple of days about using within the firm, but also using it for sustainability in other firms and sectors. Sherry's now going to jump in and think through some examples or some thoughts from industry around these two different ways of looking at sustainability.
Right. So, as you said, there's, and we kind of look at the sector of additive manufacturing kind of into two groups, right? There's sort of the AM technology developers and the AM technology users. So they kind of approach this from a different perspective, potentially. If you're talking about a company that's producing maybe filaments or powders or the 3D printers or the software for the development, that is a question for them. Are they looking at sustainability from sort of their own operational perspective? I think many are. But also, are they really effectively leveraging this great sustainability tool that they are providing their customers? And do they understand really what that leverage potential is? Because I think it's really significant what this enables AM users to do. And so really looking at it from both of those perspectives. And then for the AM technology users, how are they leveraging this within their organizations? Quite often for a big manufacturer, the AM portion of that may be a very small part of their business. And so how are they leveraging that, internally within their own organization to really promote this as a sustainability driver within their organizations and really leveraging that? And so part of the question for our audience too is sort of, where you are sort of in your journeys along that. We'll talk about that a little bit more, but really looking at understanding those different ways of viewing it. I know I had a conversation once with one of the big metal printer manufacturers, and they said, our machines have a lot of lasers and use a lot of energy, and we're really not sure where our sustainability story is. And I said, your sustainability story is not that. It's what are you enabling your customers to do to be able to produce things more efficiently, more effectively, not ship parts all over the world, do part consolidation, some of these other things they were able to do. And really, that's where their sustainability story really is, where it goes from being increasing, or decreasing their environmental impact by percentages to really doing it by factors and really being able to leverage this in a big way. And so, I'd be interested to know from some of our people who have called in and are on the call, where do they see, their organizations in this process? Do you feel like your organization is effectively implementing AM as a real sustainability driver? Are you just getting started? Sort of where do you think maybe you are. Is this a good time, Jennifer, to kind of ask for some input, or?
We're jumping ahead slightly, but I think absolutely
Oh,
that's
okay.
fine. I'm fine with that.
Okay. Yeah, so, I think, as we look at this, I think there's just a number of ways of looking at it and understanding how companies are doing this. I know I talk to companies that are using additive as a way of doing part repair, especially for big equipment, being able to add material, machine it, being able to reduce the potential for moving parts around, and not having to dispose of parts. Also being able to produce things, as we're going to be talking about design, being able to design parts more efficiently, being able to use not only less material, less energy, creating less waste. And for, as mentioned, when Jennifer said part of this talk around sustainability comes from the government, that conversation is a little bit different in Europe and the UK than it is in the US. In Europe and UK, you can talk very much about sustainability as its own topic because it's being required. In the US, the conversation is a little bit different. You can't talk about sustainability without talking about the economics at the same time. Because if you talk about sustainability in the US, the first thing people are going to say is, what is it going to cost? And I really firmly believe that these things track together. The economics and the environmental track together. They're not at odds. If you're using less energy, less material, creating less waste that you have to do something, pay to do something with, those are great economic drivers, and those are great sustainability drivers. And so understanding that and really looking at this from a full supply chain perspective, I think really is where we need to look at this. And if we get, while we need to look at the specifics around material production and part-to-part comparison and some of those things, really it's also important to look at those bigger business impacts, which I know Jennifer works on a lot in her work at the university, looking at supply chain impacts and things like that. So yeah, I think looking at that and understanding in each use case really where those potential gains are is really important.
Great, thank you, Sherry. I'm going to move on because we were also thinking about some of the challenges around this, and I think there's a certain inevitability about having to address some of these sustainability issues. It feels as if the world is on fire, but that doesn't necessarily always translate into positive outcomes in the business sense when businesses are under pressure and sectors are under pressure. There's uncertainty around this, and there's certainly a lack of guidance. So if in any small way we can contribute to that and start a conversation around how we can have more meaningful conversations and debate around this, I think it would benefit the sector as a whole. Sherry and I had a very interesting conversation around greenwashing, and I was very hardline, and I said, oh, it's terrible, there should be no greenwashing. Obviously, this is the term used by businesses who present green credentials that once examined quickly fold and are deemed revealed to not be true. So there is this pressure on firms to present this sustainable impression. Sherry was actually much more encouraging in the sense that, go on, Sherry, you tell me your counter argument.
Yeah, so obviously greenwashing is an issue, when people are claiming to, when they're just kind of virtue signaling, oh, we want to do all these great things, but they don't really want to do it. I'm careful with the term greenwashing. I think, what is one person's greenwashing is another person's just getting started. Sometimes you see companies doing, sort of going for that low hanging fruit. What are the easy things they can do to begin with, whether it's recycling water bottles in their facility or, any of a number of things that some folks will look at and say, well, that's not really a big impact, but maybe it's just getting started and it's starting to build a culture, getting people on board with thinking about things in this sustainable, more environmentally friendly way. And so really, to me, it's more a matter of intention and what they do over time. So if they just do some simple things, hey, if people want to go plant trees, great, go plant trees. But I always say you're not going to plant your way out of this. We have a lot more work to do. But if that's where you're starting, great. Let's encourage one another. If you see another company just getting started, applaud them and offer to provide some other ideas of things that they might be able to do. But I think over time is where you really see, is this greenwashing or is that just them getting started? So I think we have to be careful with that. Sometimes companies, because of their resources or their culture, they're a little bit farther ahead. And that's great. That's fantastic. But for the others, I think we encourage everybody to do what you can. Start small. Everybody needs to start somewhere and get on board. But I think really it's one of those things where time really tells what their intention is and if they're really moving forward with it. So yeah, so that I'll step down off my soapbox about greenwashing now.
Thanks, Sherry. For about a year, I've been saying sustainability is a journey, and that's based on some work I've done on a related sector, which I'll talk a bit more about in a moment. And I think by that, I'm trying to highlight the fact that you have to start somewhere. And no business is going to become circular overnight, for example. When we can all start somewhere, and valuing where you start and the small gains that you start to have is really important. But I think I'm also going to start talking about sustainability about choices and about understanding the options that are open to you, and identifying where to start and thinking, as Sherry said, where's the low-hanging fruit that can be a stepping stone to then having much larger gains in terms of sustainability. The work I did on eco-friendly activewear came about with conversations with collaborators at the University of Birmingham and in the US around the fact that you could buy some very expensive black leggings to do your workout in, or you can buy cheap. And I hope most of us have enough awareness of fast fashion and some of the very catastrophic environmental impacts that come from the amount of clothes that end up in landfill. So there's a lot of disruptive SMEs, and we've been tracking them across North America and Europe, 80 of these firms we've been tracking for several years. And they are developing very strong sustainability profiles, and they're evidencing the sustainability approaches that they're taking. And some of these start with a particular approach and then going on to becoming fully circular. So they're developing things within their business and their value proposition that allows them to charge more for these clothes, and the consumers pay more for these clothes. Of those 80 that we've been tracking, 60 should have failed in their first 3 years. 60% should have failed in their first 3 years. Of the 80 we've been tracking, only 5 have failed. So that's a disproportionately high rate of success. So there is a relationship here between taking the sustainable approach with these value propositions around sustainability that has increased their business sustainability. There is a very small proportion of these SMEs that might be vanity projects. So we could discount those, but still not enough of those to kind of counteract this argument about business sustainability. These firms will make choices. Some will focus on net zero factories. They'll focus on the social sustainability, the conditions of the workers, for example. They plan out thinking about their supply chains. If you've heard of Vija Trainers, they're a French company, and they noticed that a lot of their inputs, particularly the rubber, was coming from Brazil. And they work very closely with the rubber manufacturers, and they pay them above fair trade prices and have a very close relationship with them. And they didn't then know where to manufacture. They didn't know whether to bring the rubber back to France and produce locally to then export. And in the end, they decided that container shipping had a very relatively low carbon footprint. So they do nearly all their production and packaging in Brazil and then ship globally from Brazil. So you see this is having the right access to the data, but also making these decisions about these supply chains. And not every firm has the same solution, which raises for us the number of possibilities that exist. Other firms are spending a lot of time developing materials, doing biomaterials, thinking about what happens to that material after it is finished. Others are thinking more about design of the clothes, making sure that they last longer, enabling repair of those. I mean, there's not much repair in leggings, to be fair. We're thinking about more longer term items here, but making those decisions around design and only having simple colours not having seasonal colours, and making these kind of decisions around how they manufacture. So it's a related example, but I just wanted to highlight that these are very disruptive firms, but that are now influencing the large firms. So you'll see they use, and have been for many years, using recycled polyester. You've plastics from fishing nets, from plastic bottles, and you'll now see high street retailers doing the same. Companies like H&M, for example, or Marks and Spencer's. You'll see clothes where they're advertising how much of it is recycled. There's a whole different debate about whether we should be encouraging this pipeline of plastic, but I'd save that for another day. So yeah, thinking stages about manufacturing, and the more time these firms spend developing their sustainability credentials, the more they tend to come on towards taking a circular approach. And that's where far more attention is paid to what happens to the product after it's reached the consumer. So the post-consumer part of a circular economy is really important. And when I think about that with additive manufacturing, I think about all those points in a circular journey of these resources and these products where AM can potentially make a difference. We can design around the R's. So the R's, I mean, you could also debate this all day, how many R's there are. Some people, they think there's 5, there's 9, there's 11. So recycle, remanufacture, reuse, even rot is one. And thinking about what happens to this product after it's finished or not finished. So extending that end of life, or does it transform into something else? Does the circle move on to something else? And I think we can think about this in AM if we think about powders, for example. Powders for aerospace might be deemed to no longer be high enough quality, but they could go on to another circle, to another loop essentially, and could have a new life where that quality, that grade is good enough. Around production, we can think about resource efficient, going back to design, and I can say some buzzwords and you in the room will know, thinking about designing to extend the life. And that becomes really important with the economic rationale when we think about things like lightweighting. So the initial extra cost of using AM to design and manufacture something might end up over the lifetime of a product having significant gains. In production, we can think about resource efficiency. So we can think about the ways in which AM can increase resource efficiency. A particular one here is around reducing waste. I think there's a certain hesitancy, and for a couple of years when I go to things like TCT and other conferences and Formnext, there's a certain fear of thinking about AM and sustainability and thinking about high energy use and high use of plastics and extractive metals resources. And I think probably all of the people on this call know that that's not strictly true because they're here and they want to think about this a lot more. But I think there's definite potential around production and resource efficiency. Something we're not talking about so much in this sector that is very important in others, and I use the clothes example because we don't want to see children or people making clothes in unhealthy working environments, to reduce modern slavery, is actually thinking about working conditions. And I don't think we've really started a conversation yet about how AM might transform a factory to mean that working conditions are much more favourable. I mean, the extension of the factory of the future means that there may be less humans in that factory, total less humans. But thinking about these working conditions is a conversation that I haven't really heard started in this sector. A lot around warehousing and logistics. If you saw me at TCT or at MAC, I've been talking about this, about the potential for on-demand production to reduce warehousing and logistics. Of course, not everything is always going to be made with AM, nor could it be, nor should it be, but there has been a growth of the amount of land in the UK used for warehousing and logistics. Some of that's increase in online shopping, the death of the high street here, but some of that is stockpiling because of Brexit and COVID. So there's a potential there for AM to contribute in sustainability and reducing warehousing and logistics. And then on, of course, to the post-consumer. What roles could additive have in making sure we can design for remanufacture, but also, and Steve Salt from Rolls-Royce is going to talk on day 2 about repair using AM as well. So Going on to the next slide, I think enough of Sherry and I talking now, and another moment for you to reflect on
can I add
this.
in just a couple of thoughts there around some of those things? So I just wanted to introduce, we talk about the circular economy, and as you said, that can become sort of a buzzword of meaning a lot of different things. Sometimes what we're really talking about is a spiral economy, not a circular economy, right? Circular is it keeps going and stays sort of at the same level. Spiral is that it's morphing, coming back as something else and going off into another purpose. So I think that's an important distinction. I think one of the big parts here that we really miss when we're talking about additive quite often is skipping the circle altogether, right? So the whole premise of the circular economy is the premise that the part ever or component ever got manufactured. And that is a fallacy if you're implementing additive manufacturing, because one of the best environmental gains potentials with additive manufacturing is reducing overproduction. When you talk about, especially fashion, whether you're talking about shoes or clothing or belts or any of those things, but really any other kinds of good, we can think about spare parts. Reducing overproduction sometimes is your biggest potential for gain. Now, when you're doing a part for part comparison, if you're just comparing two parts, that gets lost in that process. But if you can move production closer to demand, now that might mean geographically closer, it may mean in time, in the decision process. If you can reduce that, you can really reduce the waste associated with the production, the energy consumption, material use during production, and then reduce parts that have to be trashed afterwards because they're last season's colors or that platform of machinery is no longer being maintained. So I think those are some of the areas that we need to look at from a holistic business approach that quite often is getting lost. And also when you're talking about the jobs, I think that's a really important part. And it's not only these sort of safety aspects of some of those jobs, which is clearly very important and a big potential for additive, but also in our current sort of global environment, there's a lot of discussion about reshoring. And it's not just reshoring. It's, here in the US, it's not just about bringing jobs back to the US. It may mean nearshoring. It may mean friendshoring. There's a big difference between relying for the US, relying on parts coming from Germany or the UK or France versus coming from China. That is a very different thing. Whether those jobs are coming back to Mexico, coming to Canada, nearshoring, those things are really big aspects of this too. And additive has the ability to do that in a cost-effective and more environmentally friendly way by really implementing this from a holistic business approach. And I think that's where we're really going to see some of the huge savings. This isn't Microsoft making a better typewriter. This isn't Henry Ford making a faster horse. We're talking about something very different. And if we're using traditional manufacturing as our measuring stick, quite often we really miss many of the benefits that additive has to bring and really can deliver for your customers. But we really need to talk about it and understand that. And we really, as an industry, as a sector, need many more use cases that really illustrate that point and the entire process around that. Also around recycling. For anyone who's familiar with the Lego Bottles to Bricks program, they actually suspended that program. From what I understand, it just when they really looked at everything involved, logistics of returning materials for recycling, that really does have to be considered. So, you're going to find some wins, you're going to find some losses, but really doing those holistic studies is really going to be important to understand this.
Yeah, and I think from the AM sector's point of view, for me, reshoring might be motivated by other factors, but it provides an opportunity where the firm might think about producing differently. And if labour costs become a concern because you've come closer to home, like you say, not necessarily back home, but I think I would view reshoring as a transformation of that configuration of that supply chain. It's not necessarily like for like coming back. Right. But also echo your feelings that at the moment we just get anecdotes and maybe publicised examples, particularly that are motivated by politics, if you like. So all the jobs that have come back home. So us actually trying to work out the kind of decisions that are being made, particularly by multinational firms, around how they reshore and how AM fits in, I think is fascinating. But there is, of course, a sustainability angle in bringing things closer, but bringing manufacturing closer to where it's going to be consumed. Is maybe a breakdown, and some of the work I do is around distributed manufacturing, and some of the and obviously well suited to AM, but what some of the sustainability gains could be around distributed manufacturing as well. So yeah, I think now, Sherry, should we give the audience time to think then about this, where you think you might be on a sustainability journey? Are you right at the start thinking about this? Are you coming to us as somebody who is an expert in sustainability around AM? And maybe philosophical point, what's the end point of this sustainability journey? Where is it that we want to end up? Is it back to those statements around what we think sustainability is, and how far do we think we are on that journey, really? Please contribute in the chat or shout out.
I would also be interested as part of these answers for those who are on that side of the equation of the AM users. So if you're a manufacturer using additive manufacturing, I'd be curious to know if AM is part of your organization's sort of sustainability strategy, or, you know, is it such a small part of your organization that that's not really factoring in at this point? Yeah, how far along do you think your organization is? Do you feel like you're in terms of addressing sustainability, sort of the beginner getting started, you know, well into the journey, really rocking it, really hitting it on all cylinders here? Have to come up with a different term for that. Electric cars don't have cylinders, so we'll have to change that terminology.
All guns blazing, but that's,
Yeah.
I don't want to say that in this tense,
That sounds very American.
world. Okay, Patrick's at the beginning. So Ollie's saying he's got an interest in researching the tools and methodologies to design for AM. I think that's something that's going to come out of our speaker contributions as well. Luke says he's relatively early on. AM's, so it sounds like AM's quite central then in driving some of these ideas about where sustainability gains come from, which is good to hear.
Yeah.
It's definitely a major tool. I hope we're not creating another bubble of hype around the capabilities of AM. I'm really pleased to see firms thinking, yeah, this is what can do it, but it needs to be resourced properly, doesn't it? So I wonder if that's something else that's happening within businesses, is how to actually get ideas resourced and how to actually make them happen. Beginner. Numbers, trying to put our numbers on the footprint. I mean, that isn't to be underestimated, is it? The enormity of a task, particularly if you start to think about the footprint of your suppliers as well, because you can't necessarily always get the data you need.
Yeah. I think also for some companies that are sort of getting started on their additive journey of using additive manufacturing, you know, quite often that first step is really just, you know, reproducing the exact same part with the exact same design, same material, just reproducing it. And which is great. That's a very logical first point. Let's just reproduce the part, make sure it can perform as needed, maybe before they launch into design. And that's a logical first step. But that's not really where you can evaluate the effectiveness of additive, right? At that point, you haven't really taken advantage of any of the advantages of AM in terms of design and some of the production things that you can do. So I think it's important to not have that be your analysis stage where you say, well, you know, we have the exact same part in the same quantity produced in the same place, and we didn't see a huge benefit. Like, keep going. And that's why I think these design conversations are going to be so important that we're going to have over the next couple of days.
Cool.
Yeah, Chris chimed in from
Yeah.
Brenneshaw. They're really doing some great work around sustainability and really understanding what they have in terms of a great sustainability tool for their customers and what they're doing internally within their own organization. Really commendable.
Interesting. There's an endpoint production line with high efficiency materials and energy, and designers fully aligned, engaged on design for AM. Interesting, because that's very much focusing on using the resources we have and maximizing them. Solution provider saying there's not customers not really paying attention yet. I think there might be some measures coming in the UK that will change that, a carbon tax to move away from mass manufacturing. Yeah, Stalin's echoing some of my thoughts really about how we ever move away from this very highly centralized global factories. And I think that it's the vulnerability of those supply chains that's driving a lot of reshoring rather than sustainability gains, but the two end up coming together in that rationale. And do we end up with decentralized? I think probably a regionalized global economy. So the North America, Europe and Africa, and then Asia, with centralized points of mass manufacturing, probably. I don't think we'll see my dream of distributed manufacturing, but maybe a combination.
Yeah. Well, I think the distributed manufacturing has a couple angles to it. One is geographically distributed. The other one is having it distributed over time. You know, we're so assuming that everything has to be made in such mass quantities because that's what's efficient for traditional manufacturing, that you have to produce very big quantities for it to be efficient. And with additive, that doesn't necessarily have to be the case. So the efficiency, again, of not overproducing at one point in time in one location and being able to spread that out not only has you're not being forced to do that because of traditional manufacturing constraints, but it certainly gives you resiliency and redundancy that quite often traditional manufacturing doesn't have. Being tied to a certain location, you know, for production can, as we've seen over the last few years, can be very problematic.
Excellent. Thank you, everyone, for your contributions. I think we're just going to wrap up our Sherry and I's conversation now, just really to think about where we're heading and think about, I think, barriers to sustainability, but probably also opportunities to sustainability. I don't want to be pessimistic or on the back foot in our conversations. I want us to be bold in thinking about the potential of AM. And today we're going to hear some examples of those kinds of potential. So I think what we will be discussing is kind of a collective discussion of what we feel the barriers and the opportunities are. Sherry, would you like to, I was going to encourage you to introduce the speakers now, but should we do that before they speak and we can have a short break beforehand? I would like
why don't we do that?
Yeah, let's open up now to questions from the audience. We have 5 minutes, then we'll take a short break and then we'll come back to our speakers.
Yeah, any thoughts you'd like to share on these topics would be great.
It would be useful for us as well if you can keep in the back of your minds probably what it is that you feel you need from conversations around this topic. We'd be pleased if we meet some of them, but we do need more information about where we can take this further after this event in terms of understanding a bit more about what's needed across the community. If we don't have a flurry of questions, we can have a slightly longer break.
Well, how about we'll just tease up the next section after we come back from our break. We're going to have a discussion, presentation from Maxime Legrand from Amexi, Yannick Willeman from 9T Labs, and Mark Bloomfield from ModeClicks. I think they're going to have really interesting presentations from very different perspectives and are really doing some really interesting work and working with some really interesting companies. And so I think their contributions here are going to be really interesting, and I'm really looking forward to those. So yeah, if you want to go ahead and take our break, and unless there's any other questions or comments or anything else that you'd like to see in the next couple of hours, yeah, that sounds good.
Okay, I'll give it a minute or so in case anything immediate comes in, and then we'll put up the break slide. You can all come back at 3 p.m. UK time.
Perfect. I'll have to get up and dance around in my office to keep my automatic lights to not turn off. So I won't subject you to the dancing. Jerry. Yeah, nobody needs to see that. So.
Welcome back, everyone. Are our speakers aware of the order they're speaking in, Sherry? You're muted.
Sorry about that. Yes, I believe so. We have up on our agenda is Maxime Legrand from Amexi, and I think, yeah, there he is right there in front of your beautiful new building, which is really exciting to see. Yeah, if you want to go ahead and share your screen, you can take it away.
Just for some context, 10 minutes for speakers and then 5 minutes for questions after that, and then we'll turn to the next one. Thank you very much, Maxime.
Okay, thank you. Thanks for the introduction. I will share my screen. Can you see the presentation?
Yes, we can. Thank you.
Okay. So let's get started. I would say thank you first for this first hour. It was very interesting. So the theme here is about design and sustainability. So what I'm going to talk about is from the carbon footprint to design, what is of the key aspects to keep in mind. But first, maybe a few words about Amexi and myself, for those who don't know who Amexi is. So Amexi, we're located in the Nordics, with the main office in Sweden, and then another one also in Finland. So roughly 30 people, and then so we work with additive manufacturing. So we have like 3 different departments. One focusing on research. The second one is the academy, which I'm part of. So the goal of the academy is to train and educate people. So basically help the customer to walk along their AM journey. So we help the customers on the AM journey, try to understand AM, find where to use it, etc. So yes, that's where I've been working now for 3 years at Amexi as an innovation manager. And then the third department which is the main one also, is the production. I would say from the design and optimization process, and then prototyping, and up to serial production. So we have a few machines to help us on that. So for smaller build envelopes, like to print Inconel 316 or Astaloy X. And then we have 2 quad lasers machines for aluminum and titanium. And we recently got a new SLM NXG with 12 lasers and a quite large build envelope of 600 by 600 by 600 to print in aluminium. So that was in a brief what Amexi is. So the goal that I've set myself today to try to talk to you about is first to try to help you find some tools to help your decision in terms of environmental choices. Not only based then on the economics only, but look also at the other aspects. And then also try to tell you what you should be careful about then when you design for a more sustainable products based on the tools above. So how to decide? As some of you mentioned before in the comments, so the first question you ask yourself is, can I print it? Is it feasible? Which technology to use, etc. So that's the first question to ask yourself. And then comes always the tough question, the cost. Should I print it? So does it make sense on a cost perspective, or maybe on the lead times, on the warehouse, etc. So try to find a bit the economical aspects. But what we've seen to start to appear also in the a bit recently, in the recent history, is also the question is, does it make sense from the environmental perspective, environmental aspect? And I would say that is also a bit maybe pushed by the oncoming CSRD maybe, where the companies have to do their own carbon reporting later on. That is oncoming. But then how to make sure that it makes sense from environmental aspects, we need to be able to measure it, to have some kind of LCA to be able to measure that. So life cycle assessments. So I've highlighted a few here, a few companies in additive manufacturing that have some LCA tools available. I'm not saying they are good or bad. I won't be judging on that, but just to let you know that those are there, and you can at least get in touch with them and try to understand a bit more. This list may not be also exhaustive, so it's just a few examples. So there is, on the polymer side, there is BASF, which is providing more materials in polymers. And then also on the machine side, I know that at least EOS also has their own tool for both polymer and metal, where you can measure the CO2 footprint of parts. Then also for both metal and polymers, we have these two independent bodies like AM Power or the Danish AM Hub. We've made some tools or made some studies on that. And then also, if we focus on metals, found out recently that Hydro has also the Hydro in Italy. They also have their own LCA tool. And at Amexi, we've also developed our own tool. So why developed our own tool? For one reason is that we found out we need also more data, more precise data to be able to be as accurate as possible. So we started to do our own LCA, and that covers several aspects. We talk about circular economy, so we talk about several aspects. So the first step is the material extraction. That is covered by our LCA, but that relies not on data, but on database, so on database that are available online, etc. So for that, we have not made like measurements, etc. Then we have the manufacturing, and that is a key point of the LCA we have developed, is that we have taken the opportunity to put some sensors on the machine to measure how much argon is used in the process, how much electricity is used in the process. So on that, we've made some measurements, try to measure it as accurately as possible. And then transportation, and of course, is covered by some database. The use phase is excluded because we don't have any power on that. So the customer has more knowledge on that. But I would say that I really encourage you to look into that phase, because that's usually where you can get also the most benefits if you think about weight saving and a part that is going to be transported from one place to another. So the less weight, the less energy is required to move that part around. So the usage phase, even though it's excluded, really encourage a customer to look into that. And then for now, the disposal is also excluded. So if you want to get this estimation, what we need is inputs. Basically, it's the same as for a quote. We need a part. We need to know how many parts we're going to print, etc. We can fit them because the factors of influence will be more like the weight of the part, how many parts you put in the chamber, the build rate, how many supports you have on your parts. So those are some factors of influence. And as I said, the use phase can be a huge determining factor also there. But let's look a bit more at some results. So we did a print job. I cannot show it to you because this one was confidential. The came to the material was aluminium and printed on our SLM 500 quad laser. And then from that, we used the tool that we developed and took the hypothesis of a global energy mix. And then, so we took first the global energy mix, and then we did the same with the Sweden energy mix. And we went down from around 280 kilogram of CO2 equivalent to a bit less than 70. So 4 times lower. So how is that possible? Say the first thing, maybe for those who are maybe not so aware, that Sweden has a very good energy mix, a very highly decarbonized energy. So that's also already one learning from this, is that if you produce locally, if you produce in countries with this good energy mix, energy production, then you're already making quite intense savings there. So produce locally, and then you get some nice energy mix, and also you save on transportation costs. So you don't need to transport, use trucks, boats, or planes to transport the part to somewhere else in the world. And then if you look a bit closer at the Sweden graph, you see that the powder production accounts for roughly 70% of the kilogram of CO2 emitted. So 70% comes from powder production. And then if you look at the column on the right, you can see that the raw material extraction is the main aspect there, and accounts for roughly 56%, while the argon and electricity are much lower. So 17% for the argon and 7% for the electricity. But if you jump back to the global one, you see that the argon has a much higher impact there because the way it's produced, maybe using coal, etc. So that depends a lot on where you produce. So that you have to be very careful about. The results you have in one country will be different in another one. But I wanted to say you don't have to trust only our tool on that. So we did this work also that was before with the Danish AIM Hub, and then another company that was specialized in LCA. And they did all of this work based on database, and they go through the same steps, more or less, so raw material extraction, manufacturing, transport, and then they added also the end of life. So that's to produce this bracket that you see there in yellow. And it was estimated versus a machined one. And of course, if you machine a block of 10 kilos of aluminium or you print a part of 1 kilogram, you will see a huge difference in terms of carbon footprint. So this showed that in that case, AM was quite interesting because it saved a lot of material. And I don't know if you remember what I told you, with our tool, we got roughly 70% from the powder manufacturing. And that's something that you can see here also. It's, again, here, the powder here, it's around 75% again. So you can see it's not, so this analysis also confirmed that the manufacturing of the powder is a So what to take away from that? So use as little material as possible. Try to be resource efficient. So that will benefit you in all aspects. You will decrease the printing time, simplified way. You will also decrease the cost of your part. And you will also then lower the environmental footprint. So that's quite an interesting way to do. So try to use as little material as possible. So maybe for you to take away, what I would say is that, you see there are some tools that are starting to be available and developed to estimate the kilograms of CO2 emitted when producing the AM part. And not so many, it's just the beginning, and I hope there will be more than that in the future. So to be able to compare also the data and make sure that we got good results, etc. Don't hesitate then to check with the local supplier what he has in his pipeline. And then I would say, maybe it seems a bit obvious in a way, it's still important to know that minimizing the amount of material used is a sure way to minimize both cost, but also then the environmental impact. Thank you.
Yeah, great presentation. Really good analysis that you all have done there. Opening this up, do we have any other questions? Well, I'll throw a message or a question out there. What areas do you see that we need to get more maybe primary data, or were you able to get data throughout that path, or was that still part of the challenge for you?
So from what I see, so at least what is missing more on at least on our side is we see that the material has a big impact, but for that we still rely for now on database. We don't have the data. So better information on the material, the powder production would be a very good way to start, I would say, or to improve.
Excellent, excellent. Any other questions? Chris said, "Wow, I need to go reevaluate our argon numbers." Yeah, it is. Go ahead.
I was just going to follow on because your question preempted mine, really. I was really interested in what you were saying about the usage phase and having data from your customers. So it sounds as if you've done a lot of work internally around the numbers, but externally getting the data in is much more problematic. Is there any route to getting that data from customers, and how would you go about it?
So yeah, what we do is deliver the part to the customer, and after he's the one using it. So he's the one. It was the one also will need that data in the future. So I would say that's more on his responsibility there. Mm-hmm. There is not so much we can do. That data might be interesting for us when we try to talk to people, to educate them about the benefits of additive manufacturing, of course. But that's also something that's also hard for them to get.
Thank you. Jonathan Rowley's asking, you've done analysis on individual parts. Have you done any evaluation on mixed full builds?
So the build there was a full build. I don't have the details if it was all the same parts or not. I would say we are just also at the beginning. This tool we have just started to test it, etc. So it's still the beginning there, of course. But then we are getting more and more data, and the goal is to we have the sensors available on the machine, so we can gather the data also for each jobs, or we can take a mean on that also.
Steve brings up a interesting point around the energy mix in different locations, and how in the UK that's broken into different regions. I know some countries in Europe it's a single grid, so a single value for that energy. I know in the US it is very broken up, so the location is very important to have that and not just use averages. Yeah, good point on that.
Even in Sweden, I would say so here I took the average because it was a bit better to see on the map. But even in Sweden, it's also 4 regions, and the north there is a lot of hydroelectricity. So yes. But then in the north, we have to ship the parts to the south or so that may be more tricky on that side. So we have to compromise a bit in between.
Yeah, absolutely. All that algebra back in school will come in handy, calculating all that. So, well, thank you, Maxime. This was great, great presentation. If we don't have any other questions there, we'll move on to our next presenter. Our next presenter is Yannick Willemin from 9T Labs. And if you're ready, we'll let you go ahead and take over the screen.
Sure. Thank you, Sherry. I hope you can hear me. You can see the presentation.
Yeah.
Amazing. Merci beaucoup, Maxime. And yeah, thanks for Amexi to start the presentations. Say hi to Merve and Manya also from my side. And yeah, let's kickstart. So now we go from a platform like Amexi with multiple technologies to 9T Labs. So who is 9T Labs? Just very quickly, we are a young company, I'd say, founded 2018 as a spin-off of the University of Zurich. We have our main site here in Zurich, Switzerland, with 40 people, and we have 5 people in North America, nearby Boston. And what basically we do, I mean, we started with the goal to really advance high performance applications. I will show an example afterward. But we really put a focus on sustainability because obviously nowadays, if you go into a factory for metal parts, you will see it's highly automated. And then when you go into a factory for composite parts, which is normally associated with high performance, we know it from sports, from aerospace, then you would be surprised how many people are around and how manual it is and tedious often. And we see a point to make high performance materials in a high performance manner. And then, of course, the question is how can we make applications more sustainable without compromising this performance, this mechanical performance, which is mainly the goal of using these materials. And so on the material choice already, because there's different types of resins. So obviously a composite is a mix between fibers, in our case, continuous fibers, and the resin. And we are selecting the thermoplastics because they have also an advantage when it comes to recycle or even during the production, as we will see, to really keep the sustainability point, but also the scalability point, because we are obviously using additive manufacturing for serial part manufacturing, which is kind of sometimes non-obvious use of 3D printing, but it will come there. So recyclability is a big topic by reprocessing some material, end of life, or basically production waste material. And also, of course, keeping the high performance, which is key for our customers to select this material, especially when it's about substituting metal parts to get lighter part at same performance. So that's in a nutshell what we are doing. We're working on several pillars. We start at the digital pillar. So it means we have a software, design software, where based on load case and geometry, we can really define where to put these continuous fibers, which are, of course, very important for the performance, but are also, I would say, bad on a cost point of view and eventually also on an environmental point of view, because these carbon fibers, obviously, they are mostly coming from petrol-based materials and they require a lot of temperature to basically get carbonized. That's why we say carbon fiber, to reach their final properties. So using them when it makes sense, when they add value in life, but don't put them everywhere. Then we can simulate and validate those parts in this digital environment, which is already part also of making a product, say, less negative, impactful on the environment, because we don't have a physical item now. Once it's verified, we go to an additive manufacturing step. That's one of the 3D printing pillars we are using. Why we are here today. Here, it's really about hitting the automation topics and the no waste topic. Afterward, we take those preforms, we bring them to the second step, which is more classic. It's compression molding, where we get the final properties. But I will walk you through a very precise example so that we can speak about precise geometry and also about numbers at the end. So here we go. So this is a rocker link for motorbike. So it's the link between the chassis, the suspension system, and the rear axle. We get this part in aluminum. So this is how it is on the motorbike today. And there we decide, based on the load case and the geometry, which is given by the customer, where to place these continuous fibers. As you see, we don't need a lot of them for the load case, we just need these 2 loops very precisely. And then we can even hybridize it with some other materials. Can be short fibers to fill the volume, short fibers coming from waste streams. And also here an organosheet in the middle for torsion stiffness. So we place this digitally. We can test it both for the processability and for the end use case. Obviously, once it's validated, we send it to the printer. The printer's goal, basically, what we are looking with 3D printing is not to get a part which is perfect coming out of the printer. We want to have a very automated way to precisely place these continuous fibers without producing any waste. So we don't want to have cutouts or milling afterward. So we do this very precise deposition here, and the end product is a preform. And this preform afterward, we go into a molding step. So obviously we go for high volumes between 1,000 and 100,000 parts. We believe it's also a way to have a bigger impact, because obviously we have 100,000 parts out there versus single parts here and there. And why we do molding is really to have this high precision. So the highest characteristics for this type of materials, the repeatability on tolerances and quality, and obviously having very reliable parts. And here we maximize the steps within one process. So we consolidate the part, we reshape it. That's also an advantage of thermoplastics. And we can integrate metal inserts, which is often necessary for the interface, as a rocker link would interface obviously with ball bearings and so on. So here we have the 2-step manufacturing. We add a 3rd step, which is the digital manufacturing before that. As I said, I mean, to be remembered, what we do, we are using 3D printing in a hybrid way. So the goal, obviously, the trigger for the customers is to reduce weight, which we understand in the use phase has a major advantage on reducing consumption, increasing payload, whatever the incentive. We have that with 0 waste, which obviously must be combined with having cost competitiveness, because we are going for CL parts and often substituting metal parts, aluminium, for example, where often the business case is pretty tough, actually, when we look at cycling or aerospace. Here's one example, a bit more going even advanced into how to reuse waste with this technology, so doing a hybrid concept. So this is in aerospace. We worked here with Diehl Aviation, which is a renowned company in the cabin interior parts. So basically we print the preforms, which you see here in the middle. It's around 20% of the final volume of the entire part, and 80% is actually scrap coming from cutouts, which is reprocessed in shorter fibers, and the preforms and the short fibers are co-molded all together in the fusion module. And then there's a final part, which is structural with 80% waste inside, having half of the weight of the aluminium part, which is a benchmark today in the cabin. Looking at some numbers, so obviously we had to test the mechanical strengths. So there was a first test with short fiber only. So this is, and then we did the combination continuous fiber preform and short fiber together. Obviously, you get an edge. You double the onset of failure load, and this is the same if you put some waste materials inside. So we proved that the waste material has no significant negative impact on the mechanical side. And we did an LCA here with the university using, I would say, commercial softwares in this field, and comparing the aluminium parts with our concept. You see there is a dramatic reduction also on the kilogram CO2 equivalent, thus also demonstrating that the concept, both in the production and in use, has a major impact. So those are fields where this technology is currently used. So wearables, luxury, sports, and aerospace. Medical could be an option, but is a bit more further in the time. So yeah, in a nutshell, that's what we are doing now, and I'm glad that you listened, and I'm super happy if you want to ask questions, challenge some of the assumptions. Your turn.
Yeah, thank you. That was a really great presentation. What you guys are doing and is really pretty remarkable in the impacts this is having, especially from your analysis there. What other kinds of, when you were talking about some of the wastes going in there, what other kinds of wastes are you able to make use of?
There's different waste streams. Obviously, there is, I would say, virgin waste, which would be at the material producers when they produce, for example, UD tapes with continuous fiber and pre-impregnated with resin. They are always cutting 1 centimeter left and right. So this is very clean waste. We have no issue to requalify it. That would be option one. Second option is cut out. So when a producer is buying these textiles and just cuts out some of the surface, that would be reprocessed. So that would also be clean waste. And then the third case is end of life. So we also took these brackets, shredded them, and repurpose them back, at least part of them. That would be the third option. Very interesting from the pitch, very difficult to apply in aerospace, because qualifying a material end of life is pretty tricky. But for sport application, it also has a nice case, I would say. So sports and luxury would be interesting. Aerospace is always tricky for whatever comes to recycling, because you also need to guarantee waste over 10 years, which is kind of counterintuitive.
Right, yeah. Oh, interesting, very interesting. Let's see, Jonathan asks, what are the molds made of and how are they made?
Yeah, very good question. So very classic actually here. These are metal molds because they are really meant for higher volumes. They are made pretty traditionally. So of course, many people are asking, why not 3D printing molds? The 3D printing molds is still more, it still adds costs versus classic mold manufacturing. It's only interesting if you really add functions, let's say very complex channeling pipe inside of the block, then it would make sense. For now, we remain pretty classic on this side.
Great. Do I have any other questions for Yannick? Right. Well, thank you. Thank you for joining in today. This is a great presentation. I always love hearing what you guys are working on. It's always some really interesting use cases, and I think really demonstrating some interesting applications and some kind of different ways of attacking the sustainability and where additive can be applied. So yeah, thank you.
Thank you.
All righty. Yeah, thank you. Hey, okay, everyone. Our next speaker up is going to be Mark Bloomfield from ModeClicks. You can go ahead and jump in here, Mark. And thanks for joining us today. Appreciate it. And really looking forward to this.
Thank you, Sherry. Just setting up, share my screen. Is that all good? Everybody see?
Got it.
You can hear me clearly.
Yeah.
Brilliant. Okay. Sherry, Yannick, Jennifer, and Maxime, thank you for setting this up. It's been very, very insightful. I'm coming at this from a slightly different angle. My name is Mark Bloomfield. I'm a designer, maker by trade. I trained to be a jeweler and have been working, I suppose, professionally for around about sort of 30 plus years across a variety of different industries. So this goes from predominantly a sort of fashion background, looking at fashion jewelry, manufacturing across different sort of manufacturing centers around the world, different supply chain setups. The impact of technology within all of that, it's kind of trying to combine traditional sort of ways of manufacture with what these new technologies have to offer. And then a bit later on, I sort of got involved with my own company, Electrobloom, which I set up about 15 years ago, specifically to look at additive and how I could begin to maybe address some of the things I was feeling about the atrocities that I was witnessing in the fashion industry, for example, and how we could sort of, I suppose, take a more holistic approach to the manufacture of jewelry, to look at reshoring, to look at sort of making locally, distributed manufacturing, but also to look at sort of component-based design processes. So very much taking a modular approach and using that to kind of engage customers, but also as a way of actually managing, stock, and also looking at the extending the versatility, I suppose, in those parts that you actually have manufactured. So it's almost as if, I think, Jonathan is really keen on sort of the term of ModeClicks is like Lego for clothes, where it is that sort of playful kind of attitude and sort of way in which you can engage with the material, and you can just keep making things and just keep reusing the sort of same components. So I was partly sort of involved in education as well. I've always been teaching, and I got sort of involved as a researcher up at the University of Hertfordshire, where I was working with Sean Borstrock. We set up the Digital Hack Lab, and one of the first questions that we asked ourselves, we just sort of invested in an EOS SLS machine, and we wanted to kind of understand whether or not we could 3D print clothing. So this was about understanding, I suppose, the capability of the machine. It's a powder-based machine, so in terms of support material and being able to clean and actually kind of post-process, was at a minimum, meant that we could have complete sort of design freedom when it came to actually designing and developing some ideas for flexible forms. So these were some of the initial early stage kind of chain sort of mail type structures that we started to explore to see whether or not we could actually turn this into clothing. I don't know if any of you have had any experience with trying to do this, but it's really quite difficult. There are limitations in terms of the actual build volume, for example. How do you actually kind of make something that's big enough to actually clothe somebody in a sort of small 20 by 20 by 20 sort of build volume? It's also, once you've actually kind of figured that out, how do you actually make it fit somebody? And when they actually try it on, how do you sort of handle their sort of questions when they kind of ask you, oh yeah, well, it's nice, but it's a bit tight here, or can you just let that out a bit? So there are all these, I suppose, challenges that we needed to try and overcome. One of the initial sort of things that we did was to try and kind of compress, a pattern of a theoretical garment using physics to kind of fit into the build volume. So this works. It's something that software can manage and can do. But we sort of had a problem when this came out because some of the links had failed in this simulation process and were no longer linked together. So it was kind of, then I was kind of looking at it and thinking, well, that's a waste. I've not got to throw that away. This isn't working. And then it was kind of, well, maybe I could just, if I could put these two links back together again, if I could just click them together, then that would hopefully solve the problem. So that's how sort of ModeClicks was kind of born. And I hasten to add that this wasn't a sustainability project. This is really just looking at whether or not we could print clothing. The sustainability, I suppose, came as an afterthought, really, because we started to basically just play with this, develop this link, which you can see on the screen. It's open on the back. So it just means that these kind of small clover-like links can be linked together. and they can be sort of printed as linked sheets. So we could print sort of large panels that just come out of the machine, just shake them off, get rid of all the powder, put them through a sort of vibro finishing process, and then you can start linking sheets together. So you can start actually building much bigger things with it. So this is one of the first things we actually built. And I think this dress kind of shows quite nicely how you can sort of see some of those sort of square panels actually kind of fitting together, and how that begins to kind of actually conform and fit, you know, the shape of the actual the mannequin in this instance. And it was a really nice sort of way of beginning to understand how we could actually build with this material, and also beginning to get some idea of what the capabilities would get, you know, what could we do with it. So, you know, this dress has actually been worn by 3 or 4 different models. Each of them have different body shapes. But we've not had to take the whole dress apart. We can literally just take links out and we can sort of reshape it so that we can actually make it fit pretty much anybody. So it began to kind of, I suppose, introduce us to this idea that this was something that we could actually, you know, tailor. And we could tailor it over and over and over again. So it was really kind of fitting that whole sort of circular economy sort of model, whereby the material itself is something that we can just print, and then we can just continually find new use for it. And we don't ever have to throw it away because we can always reuse it. And we sort of then kind of figured that we could actually make new parts that could kind of fit into this concept, so that we could actually expand its capability. So we came up with another couple of links. So you see the blue panel on this, for example, has a actual flat sort of square panel on the top surface, but it has the same linking mechanism underneath. So again, it gives us a very different sort of look, and it also gives us, interestingly, some sort of mechanical properties, which are different to the regular links, which I'll sort of talk about a bit later on. This dress also sort of includes a setting. So this actually is set with about 20,000 little sort of Swarovski crystals. So it sparkles like crazy, and it moves and flows, you know, and it's very easy to wear and to put on. But it kind of meant that what we were now doing is we were sort of already building on a concept that we have developed, and we were sort of, I suppose, giving it new capability. We were sort of breathing new life into it just by introducing a new sort of component. And we sort of went on and we did this. We did several shows. We kind of, this was in Denmark, in Aarhus Walks on Water. We did this show twice, and each time, you know, it's a great sort of occasion where, you know, the models all get very excited about sort of being fitted into a garment that's made to kind of fit them. And then also there's lots of sort of questions around the actual material, and about, you know, how it's made. And when we sort of talk about what it's 3D printed, you know, it's kind of something which they sort of really get sort of blown away by. But it just meant that we were able to start to really understand this idea of, well, this is a, you know, an additively manufactured material. We can continually sort of adjust it, we can reconfigure it, we can refine it. And it's also about how we sort of maintain it. You know, we can sort of, if one of the links, for example, breaks, you know, we can just replace it. So there's all those kind of, I suppose, good plus points from a sustainability perspective, which also engages the user. And I suppose it's that sort of way in which we started to kind of talk about it, and how that then sort of rubbed off on customers, on people that would come in and people that we would actually show these items to. Also working with other, you know, we work with Ben Ein, who's a street artist, with one of his letters, the Z that you see on the dress in the middle there. So it's also kind of understanding how other designers might sort of work with it and what their aspirations might be. The model on the left is obviously full length, so we were quite pleased to be able to actually kind of get, you know, all of that material out to actually kind of make a garment that could essentially sort of be as big as a person. And all along, you know, we're kind of conscious of how we can actually kind of take this material and actually kind of then reuse it, and how we can sort of then turn it into other things. So we're always trying to kind of extend its use, expand its use. But also by doing that, it's also how do we also, we don't necessarily want it to cycle down the way whereby it becomes less valuable. It's how do we go up the other way and sort of make it more valuable. So particularly when we start looking at jewelry, for example, these are some ideas for actually kind of making necklaces, but also explorations in terms of the mechanical properties of the material and about how sort of using those different sort of components in different ways, about how they actually change the rigidity and the structure of the actual object that you're building. And this has become quite, I did these for an art show. I had an exhibition up at the Lowry in Manchester. And some of these objects were made specifically as a result of playing with the material. And they are odd in that they don't necessarily respond when you sort of handle them. You know, they're sort of interactive sort of art objects. They're like sculptural forms. But they're also quite good. You know, we've had lots of requests from people thinking, well, this could be my new sort of relaxation sort of toy. And it's how, I suppose, the, you know, when you start questioning an object and you start sort of feeling and responding to it in different ways, it also begins to kind of engage the customer, engage people in these very important sort of considerations around things like sustainability. And about material use. It's getting people interested in, you know, everybody has a question about how is this made? How do you get it to do that? You know, and then talking about, well, we can take it all apart and we can turn it into something else. They kind of, you know, light bulbs go off and they kind of feel like, oh, yes, you know, they kind of get it. So it's been a really good sort of vehicle for beginning to kind of talk about those things. And also, I think, you know, it's sustainability, you know, it's I think one of the main barriers, and one of the biggest things that ultimately it's all about behavior change. You know, it's about us actually kind of looking at the you know, what we currently do and how can we actually change those mechanisms for the better in order to begin to kind of solve some of these problems. I put in there a little challenge thing because obviously one of the things that I'm getting is that it's still plastic. So this is still a challenge where there does seem to be, you know, plastic at the moment is having a real hard time because it's something I think that customers understand. Plastic, they only understand it as one thing rather than a full spectrum of different materials. And also because, you know, I'm using a powder-based system, it's the powder, you know, it's a microplastic. Bureaus have got a lot better. I think the last order I came in from 3D Print UK was powder free. I was pretty impressed. There was absolutely nothing on it, which is really good. So I think there are some things that are happening in that instance, but obviously there are some, you know, quite disastrous ways in which that could be interpreted if something's not done about it. Thank you. There's some sort of contact things there, but yes, get in touch if you'd like to know more. Ask me questions if you have any.
Yeah, Mark, this was a great presentation. Really interesting use of additive that I think is so useful. Just like the other presentations, it just kind of expands what people are thinking about and the potential for this, and just conjures up other ideas. What other interesting ideas have you heard from people who've seen this and then suggested an idea that you'd never considered before, a use for this?
I think we've pretty much covered most uses. People think about it in, we have got, somebody said, oh, we could do cushion covers. So we have done cushion covers. And that's quite a nice one because also we were thinking about, well, this could be quite good on yachts, you know, for, you know, because of the nature of the material. We had some things with, one of the other things we were looking at doing also is change, it has a certain amount of stretch. So there's also in terms of how you could use it to be supportive in a sort of medical context, for example, because we can sort of change the actual, you know, we can change the stretch on the links so that we can just make those thicker or thinner and begin to do that in a localized way. So there are things that are quite, yeah, interesting to kind of think about and do more with. It's also, you know, simple things like keeping track of material and where is it and who's got it and getting it back and track and trace, all of that kind of stuff is quite a challenge. But yeah.
Yeah, really interesting stuff, and it's great to get it in your hands. I know when I had an opportunity to touch it and feel it, interact with it, it was really very interesting. Do you have any other questions out there?
I'll leap in then. Thank you very much, Mark. I had an observation, but also a question as well. The question is, how do you clean it? But then the observation is, I think this is great for children because you don't have to keep replacing their clothes. You can just add new links as they grow. So is that an uncaptured market, maybe?
Yeah, no, absolutely. I think that would be a really good one. And also, I think it's nice where, you know, the kids and just that idea of, I suppose, enjoying that process of actually kind of making their own clothes and being able to do it in a way which is not only about them growing, but also, you know, if they want a different kind of trim or a different cuff, or it's hot, they want to take the sleeves off, you know, different things like that, they can start to kind of think about and consider. Regarding cleaning, yes, at the moment we either dishwasher or the washing machine in a you know, in a pillow slip or something.
Thank you. Maxine's asking, question. How does it age over time? How long do you expect it to last?
Yeah, it's nylon, and it's indestructible. So that is one of its, you know, sort of pluses. Over time, it does start to absorb some, you know, stuff in the air. It is constantly absorbing, so it will yellow slightly. We can sort of freshen that up. Essentially, we can over dye. We've sort of done the whole process of starting off with, you know, lighter colors and then getting darker over time. So it always kind of moves towards, you know, black, I suppose, as being the final sort of rendition. But yes, it's something which does seem to, it's difficult to check. You know, sometimes we do get errors maybe in the build. So there might be one which has, for whatever reason, you know, a bigger base of material, or it wasn't sintered correctly. So that might create a break point. But again, you know, we can then replace, you know, so it's not as if that break point means that we can't use the entire piece of material. We can just replace that link. So there are some really good sort of benefits around being able to constantly, you know, maintain and repair it. And they're pretty robust. I mean, like I said, it's at the moment we've balanced it so that we have a certain amount of stretch in the material, but it needs to be, you know, supportive. It depends on different area, you know, as you're aware, different areas of the body move in more extreme ways depending on what you're doing. So people, you know, that have worn it have kind of highlighted this to us. Sometimes we can sort of reinforce those areas. We also have some stronger loops, for example, that we can put in, so we can reduce the stretch but increase the strength. So it's trying to kind of, I suppose, take on board all of those different considerations just to get something which is going to be fit, you know, fit for purpose. But one thing I'd say is that I think going through this journey, and that this isn't something that is going to replace your jeans and t-shirts. You know, this is more of a real sort of going out, dressing up kind of piece, which you may only wear once, you know. And so this is something which is about, you know, you sort of treating yourself, being fitted for it, going out, enjoying that moment, and then bringing it all back to us, you know, for us to then sort of clean and then return it into something else. So we're kind of thinking that that's probably the best course of action for it as a material in that context. Okay.
Brilliant. Thanks very much, Mark.
All right.
I'm going to put my camera back on. Yeah, it's very interesting you raising the issue of it coming back to you, because this is the way you control the circularity. So yeah, renting of clothes is becoming much more high profile for that reason.
Yes. Yeah.
Yeah.
And I think it's something which is good because you also then get, you know, that relationship with the customer and just how they are kind of, you know, engaged in the process more. I think is also good.
Brilliant. Unless there's any more questions, we'll take our final break and come back in 7 minutes at 4 o'clock UK time. I'll put the break slide back up and we'll have 3 more very interesting speakers. So I look forward to seeing you at 4. Thanks, everyone.
Great. See you in a few minutes.
Welcome back, everyone. It's now 4 o'clock, so nice to see you all again. It's my pleasure to introduce 3 fascinating speakers. First up, we have Clemence Poncet from Arkemia. Then we have Brian Morrison from 6K Additive, and then Milo McLaughlin Greening from Batchworks. So without hesitation, I'm now going to hand over to Clemence. So thank you very much. If you can share your screen, thank you.
Thank you. Hopefully it will work. You can see my screen full screen.
Yes.
Yeah, perfect. So good morning, everyone. Thanks for the invitation. So I'm Clemence, and I'm working for the French company, so Arkema. And I will quickly give you some updates about the novelties in terms of sustainability. So first of all, I just want to give a very few words about who is Arkema and this company. So our core mission is to develop and produce innovative materials, but also for a more sustainable world. So this is clearly our motto as of today. So we support key customers in their challenge this way. To do so, we can rely about in 21,000 people all over the world. We have about 150 plants, and we can also rely on 17 R&D centers, again based in all over the world. Because the headquarters is based in France, but we have people based either in the US or in Asia as well. To show that we are innovative, so about 3% of our R&D turnover is invested. 3% of our turnover is invested in R&D. Sorry. And for myself, so I'm Clemence. I'm working in the business development for 3D printing, and my mission is to help customers to adopt and solve their challenge around additive manufacturing. The offering of Arkema very quickly. So if we deep dive in the 3D printing, so we are serving the 3 main core technology, so liquid resin for UV curing, thermoplastic palette for filament extrusion, and thermoplastic powder for powder bed fusion, where we'll more talk about this today. So we have 3 main product lines in terms of products. So 2 first one, Rilsan PA11 and Pebax elastomer, which is for PA11 100% bio-based, and for the Pebax, which is partially bio-based. Again, I will talk later on what bio-based mean for us. But what is key to remember is that those 2 materials can offer, so for PA11, superior mechanical property, so in terms of fatigue resistance, impact resistance, for example. And the Pebax, which is quite new, it has been released on SLS machine. It's quite well known in the sports industry because it has a very high return energy. And again, it's partially bio-based. The 2 product lines below, so Orgasol PA12 and Capstone, are not bio-based. So we launched the PA12, so I'm sure you heard about it with HP, so under the name PA12S by Arkema. So what is really new on this, and again, it's come back to what was said earlier, so it has a very high reusability refresh, so it means that you can use about 80% of old powder in the machine. So again, you can, first of all, lowering the cost per part, but also you can decrease the amount of waste. And we also have developed a specific way of processing and manufacturing this Orgasol, so finally the parts have an outstanding surface smoothness. And if your application is very high demanding in terms of temperature, for example, we have what we call the Capstone, so very high performance materials. So as I said, so PA11 and Pebax are partial. So PA11 is bio-based, Pebax is partially bio-based, and it's derivated from the castor plants. So castor plants, so very easily, how does it work? So we take the castor plant, we collect the beans, then we crush it into oil, and then at Arkema we have the knowledge to make from the oil the monomer, the amino 11, and then polymerize into polyamide 11, and then having the powder for 3D printing. Why using castor is very interesting. So there is, first of all, so those beans are growing mainly in India, in the Gujarat region. There is no competition with food because it grows on marginal soils. So it means that nothing else could have grown on those soils. So it links that there is no deforestation, and it's really seen as an additional source of income for the farmer in India. So they are doing it in additionally to their main activities. And also, so when they collect the beans, so let's say half of it is going to oil and the other half of it is used as cake. So it's also sold as a fertilizer. So there is no waste. So how we can translate it into our numbers. So I think it's go back to what was said earlier in terms of life cycle analysis. So what we have decided from Arkema side, so we probably show the numbers. So saying that PA11, the number is that our product is below 2 kilograms of CO2 per kilogram of product. So when we compare this to a fossil fuel polyamide, as it's bio-based, and we also recently signed a huge bioenergy contract in France, our carbon footprint of PA11 is 17% below fossil fuel-based polyamides. And also, we have the target to always improve ourselves. So we have the target very soon to come by 2030 to propose a PA11 that is below 1 kilogram of CO2 equivalent per kilogram of products. So this is very challenging, but we'll make it. So again, to show that what we are saying has been recognized by other third parties. So we have been recently certified, and very, very proud of it, of Solar Impulse. So Solar Impulse, it's an NGO that is certifying solutions that are sustainable. Again, we are very proud because it was a very long process. They assessed the entire value chain, and having this recognition is showing that what Arkema is doing is really profitable in terms of sustainability. So this label is concerning polyamide 11 and also the Pebax, what I was saying earlier, the elastomer. And last slide, so I want to emphasize as well. So Arkema is committed. So as I say, we are manufacturing polymers, but we are also committed to until the end of life. So we have invested in 2021 in a company called Agiplast. So this company is based in Italy, but is recycling old powders or used or scraps mechanically to be reused. So it means that Arkema is committed from the manufacturing side until the end of life of the product. So how does it work easily? So we collect, if we deep dive in the polymer 3D printing area, Agiplast is collecting either used powder from additive manufacturing, used parts, or scraps. Then they bring everything into their manufacturing site in Italy, and then mechanically they are able to reprocess it into injection molding grade that will be reused in different markets. So as we can see on the slide, on a saddle, on a shoe, or something else. So this is something that we're also very proud to show that Arkema is committed from, let's say, the entire value chain of the polymers. And that's it for my side. So if you have any question or something you want to deep dive, feel free to contact me. I also put 2 useful links on the right side. So first one in the Arkema website, where there is all the info that I mentioned earlier. And the other one is the platform Easy3D that we launched very recently. So it's a tool when you have an STL file that can help you to select the right Arkema materials.
Thank you very much. That was really, really fascinating and really concise slides to give us that really good overview of what's going on in Alchemia. Lots of good work going on. I'm going to open up to other questions. I have a couple, but if the audience has any questions first. Oh, that's an answer to a previous question. I wanted to ask you a little bit about, I think that the castor beans are really interesting. And obviously a lot of thought's gone into making sure that it's the right kind of agricultural crop produced in India, in these marginal locations. How much thought has gone into the social sustainability around the working conditions, avoiding modern slavery, that kind of aspect of sustainability?
So so we can't control because there is lots of farmers, but we are committed. So we are in the Pragati program, again with all the people who are using castor beans. So for example, BASF is also part of Pragati, and this is a huge NGO that is helping farmers to, let's say, help them to make sure that they are using the good way of farming. They are making sure that children are going to schools and stuff like that. So we can't give a certificate like we can't make sure that because there is too much people, but we are committed in the Pragati program.
Okay, thank you. Some questions coming in. So Chris Rollins is asking, are biopolymers time stable, comparable to fossil-based polymers?
Yeah, they are. So I'll give an example. So it's not, so P11 is used, so as this example, it's used in additive manufacturing, but it's also used for years, more than 70 years in injection molding and extrusion. And for example, so P11 is used in offshore flexible tubes for more than 30 years, so completely time stable. Completely.
Alan asking if the recycled reprocessed powder is a lower quality, hence going to moulding rather than reuse in AM.
So the powder we collect is not reused. It will be reused in molding process, but let's say that the know-how of Agiplast is to do a compound with new powders, so it means that at the end the quality will be the same if you buy recycled grades or if you buy a new grade that is 100% new, if I understand the question well.
And all of those recycled materials are coming into one site in Italy, did you say?
They're going in injection molding only or extrusion, but not going back to additive manufacturing, because as you all know, the quality of powders needed in additive manufacturing is very high. So as of today, we prefer to use it for injection molding.
Okay, and the recyclable materials are coming in globally into the plant in Italy.
Yeah.
Okay.
Yeah.
Interesting. Okay, unless there's any more questions, I will thank you, Clémence.
Thank you very much.
Thank you for joining us. And now we shall turn to our next speaker, Brian Morrison from 6K Additive. Hi, Brian.
Hi, how are you?
Good, thanks for joining us.
Absolutely. Can you see that okay?
Brilliant, yeah. So continuing our focus on materials, I'll hand over to you, Brian. Thank you.
Yeah, thank you. So yeah, thanks for the opportunity. Like Sherry, I am actually located here on the east coast of the US. So good afternoon to everybody there in Europe. And again, thanks for the opportunity. I'm going to talk about 6K Additive. And I'm the director of sales here for North America. So quickly going through this, since we have 10 minutes, a little company overview. We are a producer of metal powders, specifically for additive manufacturing from sustainable feedstocks. We operate a operations 24/7 with a technology that supports lower CO2 footprint and higher yields. And I'll get in more to the technology that we call Unimelt, or it's a plasma spheroidization technology. The company's a little over 100 people in our division at 6K Additive. We're headquartered in Pittsburgh, Pennsylvania, with other locations in the U.S. and a team also in Europe. We are also part of the AMGTA, so we're proud to be a member of that. So like Arkema, this is actually it was a good lead in to my presentation. This slide gives a really good overview of what we do at 6K Additive, managing a wide variety of metal revert streams to upcycle that revert into additive applications, but also into recycling into other applications as well, if we're unable to put it into a spherical powder form. So you can see the different material, we refer to them as revert, that come into our company and then put into our different value streams. So things like solid scrap, machine turnings, end-of-life parts from our customers, specifically from our additive customers. We'll purchase things like failed bills, support structures as well. And we're constantly also looking for used powder or alispec powder that comes to the end of life in additive manufacturing to use in our processes. So within that, it comes into 6K. We do a lot of vetting, which I'll talk about, and it can goes into our powder business, either come out as an angular powder or a spherical powder, spherical being the powder that we sell into the additive manufacturing market. If it cannot go into that value stream, then we'll put into a mill product. We can actually remelt that revert into an ingot or prepare it as scrap to do that. Or then it goes into what we call our alloys business. These are titanium compacts that are used for alloy additions in the aluminum melting market. So whatever comes into 6K Additive in terms of revert goes out as a product. So what I'll be talking about the rest of the presentation is our spheritization process and the sustainability initiatives we have with it. The Unimelt is spun out of MIT back in 2008. Again, a plasma-based process generated by a microwave. Why that's important is compared to other plasma technologies, it has a very uniform plasma plume. So the temperature is very uniform within the plasma. Why that's important is as we are passing through the feedstock, as you can see in the top left there, that could be irregular in form. That is all exposed to that very uniform plasma plume, which is over 6,000 degree Kelvin, hence 6K. And it will actually spheritize the irregular material into a spherical particle, which you can see there on the bottom left. So we have a very high yield of the revert materials that we're preparing that go into the spheritization system and come out as premium quality powder. A little bit more of what that process looks like. Again, you can see the various raw materials that we are prepping there on the left, anywhere from powder to solid parts. Those go through a very intense vetting process where we're looking for the quality and and any cross-contamination potentially of the materials. And then we will sort those and through that process, and they'll go into those different value streams that I spoke about. And if they're going through the powder production process, they'll go through a cleaning, a milling, and a sizing process. In our process, the size of the material going in is essentially the size of the material going out. So we have to size it appropriately for the different additive manufacturing technologies that require different particle size distributions. So we size into what we call an engineered feedstock. It can look irregular like that. It could be a little more spherical depending on the raw material that's being used. And then we pass it through the spheritization system to yield the powder that is, again, spherical in nature, fit for use for additive manufacturing. There's over 31 quality checkpoints, around 31 quality checkpoints throughout the process as we go from the raw material to finally certifying the powder for use. Just when talking about sustainability, and I do want to compare our process to other processes out there, but things like plasma atomization, gas atomization, there are some challenges with the process, just like any any technology. Things like wider PSD, a lower yield, some morphology challenges when it comes to the metal powders produced from this process. Also on the top there, you can see that the atomization process does, as I mentioned, produce a very wide distribution, so the yield of the usable powder can be low. And then so the generation of waste that sometimes is either can be remelted and applying more energy to that to remelt it, or simply scrapping that, or storing it in inventory. At 6K, we can actually use some of those waste products to produce the size material that we're looking for through that milling process I spoke about. So as we pass it through the UniMelt process, again, what goes in is what comes out. You have a very high yield, up to 100% of material going through the unit. And so it's very tunable to, as we are fixing the powder size distribution up front before the production cycle. So here's a little bit of what some of the raw materials look like going in. You see things like 316L, which is a stainless steel material. This would look like a used powder that was used by an additive manufacturing OEM or contract manufacturer that we would purchase back and then pass through our system. The nickel 718, which is a nickel-based superalloy. This would be like engineered machine chips or SORF that could be then passed through the system to be spheroidized. And then the last there is a titanium alloy, very popular one, Ti64, that's used in a lot of biomedical and aerospace applications. This is irregular material that was then milled from a solid initially, and then passed through the system to, again, make a spherical powder. So a little bit about the product offerings we all make from, again, sustainable raw material sources. Things like nickel alloys, 718 and 625, used in aerospace defense applications predominantly, also in different energy applications, whether it's oil and gas or land-based turbines. We produce a lot of titanium 64, used in aerospace and defense applications, but also medical applications. And then a wide variety of very specialized high temperature, high performance alloys like niobium alloys, tantalum, tungsten, moly, and rhenium. And the flexibility of the system going up again to 6,000 degree Kelvin, we're able to melt anything from a low melting point material like aluminum to very high melt temperature alloys like tungsten. So a wide flexibility in the system we have. So a little bit on the sustainability. I spoke with our initiative at 6K is really to significantly lower the landfill material, taking a lot of these waste materials that would otherwise be scrapped and being able to upcycle them in our process, and significantly lowering the energy consumption and CO2 emissions to be able to produce powder for additive manufacturing. So we have done a life cycle assessment. Heard that several times today. So we've done that on both our nickel production, but also our titanium. So on the left, you can see the nickel side, a 91% reduction in energy use and a 91.5% reduction in carbon emissions throughout the entire process. This was a third-party assessment done by Foresight, and we're happy to share that white paper. It can be downloaded at our website. Also, you can see for the titanium side, it was roughly lower 70% reduction in energy use, and again, almost 80% reduction in carbon emissions compared to other titanium powder production processes. So yeah, that was a quick run through of what we do at 6K Additive and how we again source sustainable raw material to utilize our plasma spherization process, our UniMelt process, to make fit-for-use powder and additive manufacturing. So happy to answer any questions you guys have.
Brilliant, thank you, Brian, and an award from Sherry, no less. So.
Yes, yeah, should have.
Yes.
Oh, Maxime, how do you make sure you have the right chemical composition? How do you deal with potential contamination by different alloys?
Yeah, it's a very good question. When we're sourcing raw materials, we do bring them in and go through a very rigorous process. First, we measure the chemistry just by what we call a XRF gun. We'll shoot it and to see if it has the correct chemistry that we're looking for. If it does, then it goes through more of a intensive vetting process to our approved lab on site at 6K. And at that point, we're also testing things other than just the chemistry. And then even furthermore, we'll do other blends of material to ensure that it's homogeneous before putting into our production process. So there's more than 3 checks of the chemistry before it goes into our production process internally.
What about water-based atomization? So wondering what your opinion is and whether you've worked on it.
Yeah, so being in the additive manufacturing industry for a little while now, I know there's been a lot of work on water atomized powders. It's tend to be either gassed or plasma. Spheroidized or gas atomized powders have been used traditionally, and it's usually based on the chemistry requirements for the end-use customer. Water atomized powder in some cases can have more irregular particles, so flowability can be a challenge, and oxygen content can be a challenge. We have utilized those raw materials to run through our system to spheroidize them, improve the morphology, and lower the oxygen content as well.
Thank you. I was thinking myself about this cross-contamination of the materials because, we can think about design and also process and manufacturing process and how we handle waste. I mean, mono materials, I know makes it easier to recycle and separate things, but what are the most common causes of this cross-contamination, and what could the sources of those materials do better to make your job easier?
It's a really good question. So it's segregation, and we work with our customers, which are also our suppliers on this. It's segregating materials in certain bins and having even color coding and labels for those bins. It's when equipment can be dedicated, like screening of the powder to a certain alloy or alloy family, that's preferable. Not every company can afford to buy a singular piece of equipment, like an additive manufacturing piece of equipment for a single alloy, but that's also preferable because the changeover of those materials is very hard to ensure that it's 100% clean when you're changing that piece of equipment. So a lot of best practices that companies can use to ensure that they're not cross-contaminating their materials.
How big could this get compared to other powder manufacture? Will it always be niche, or could it take a significant share of powder manufacture market? I can anticipate your hopes, Brian, but
yeah, you're asking a sales guy about that. So you're going to get the sales guy answer to that. No, we have significant capacity. We have 4 of these plasma Unimelt systems in Pittsburgh, and expanding that capability to 4 more. So that's pretty significant capacity when you even compare to other powder suppliers in the marketplace. We also have several R&D units in the Boston area. Again, the spinoff of MIT. Our company is based out of the Boston area. So 3 more units up there where we focus on smaller production of refractory alloys. So the answer is yes, I think it's significant. We're, I would say, a very fast-growing part of the additive community when it comes to supplying metal powders.
And the experience
Brian,
high entropy alloy powder production. So Alan wants to know more about upcoming projects in that area.
So we're absolutely capable of producing high entropy alloys. And the way we do that is we take we do a blend of different materials, whether pure elements, and then we would mechanically alloy those and through a milling process, and then pass it through the plasma atomization system. So we have done that and supplied that to certain projects, and are certainly open to new projects on developing of those alloys, which is can provide very superior properties when it comes to additive.
Hey, Brian, quick question for you. Is this technology to the point where big users can have, does it make sense for them to have one of these units at their site, or is it still going to remain something where the materials come back to you guys and then go back out again?
Right, it's a really good question. We have a lot of requests from customers to eventually get to supporting them on site or having them operate one of these units on site to be able to recycle their materials. Today we're operating out of the U.S. and with plans to expand into Europe in the coming years, and then also considering that with some strategic customers, if that is a future part of our business model. Today we are operating within Pittsburgh and bringing all the raw materials back in from really all over the world, but primarily Europe and the US.
Great.
Thank you. Thanks for all those questions in the audience. Okay, so we're now going to move on to our last speaker of the day, which is Milo from Batchworks. Hi, Milo.
Hello, everyone.
Thanks for joining us.
Yeah, thanks so much. I'm pretty sure that when I share my screen, I'm not going to be able to see anyone. So, if I start a tangent or something, just bear with me. So I'm here to talk about Batchworks. Thanks so much for having me on. I think my presentation is going to be slightly less technical than the two previous. Batchworks is a manufacturing company that's using additive to really leverage ideas about circularity. Let me just share my screen. Here we go. Okay, can you see that?
Yes, we can. Thank you.
Okay, great. So Batchworks is a design and manufacture company which is really focused on leveraging ideas about circularity and distributed manufacture from its very core. We've been going since 2017. My business partner, Julian, he is trained as an architect, and he was really interested in this idea of distributed manufacture and how digital production technology can sort of bring manufacturing back to the city. He set up a sort of small farm of 7 3D printers in a shipping container in East London, and initially was just really focused on this idea of local production using this technology. And the way I got involved in working with Batchworks is that my background and research, my background is as an industrial designer. My research has always been really focused on material flows, and these sort of unicorn mystical ideas about circular economy and distributed production, which I've been learning about since I've been at university, but actually hadn't seen any really good examples of. And during the COVID pandemic, when there was a huge need for PPE, I got in touch with Julian, knowing that he had some 3D printers, and we, over a weekend, put together a really efficient design for, I'm sure you've all seen those 3D printed visors. We managed to put together a design that took 10 minutes to produce, and over a series of weeks managed to produce 10,000 items of PPE for a local hospital in London, directly for the NHS. All of those units were delivered directly by bicycle, and we were using recycled PET from a company in the Netherlands. And for me, that was a huge light bulb moment for this technology, because we'd managed to answer a need. So a supply chain was broken, and there was this sort of momentary need, and we were able to use digital production to sort of take up that need, really quickly design a product which would fit the bill, and then deliver really locally with this technology and create this really nice small material loop. So towards the end of delivering those parts to the hospital, we started working with them on how we could then recover the visors after sterilization and have them returned back to us. And this created for me this really beautiful idea of this very localized manufacturing hub where we can create these really nice small manufacturing loops. And then because it's digital, starting to dream of how this can be networked and distributed across multiple locations. So from here, Batchworks in its current format was sort of born. Julian and I started working together on really realizing this idea of distributed manufacture using digital production technology and how we can design products for specifically for circularity. And since then, we have a growing list of clients, so much more consumer focused than some of the heavy engineering projects that we've seen earlier in some of the presentations. But what we're really proud of is proving that there is a space for FDM manufacturing in this area. I think there's lots of misconceptions about 3D printing, specifically in the design and engineering world, that it's mainly only useful as a prototyping tool because it takes so long for parts to be produced. But we have, by focusing really heavily on the design process, proven that it's possible to manufacture parts super efficiently with this process, especially leaning into some of the other advantages. So some of the products that we're working on, so consumer products, we've just recently launched a pair of headphones for children on Kickstarter. That's completely made to order, and the sort of core focus of that project is looking at how we can, if we're designing with circularity and sustainability in mind from the beginning, we can start to bring in all of these ideas about repair and reuse into a product from the way that it's put together. So the Kivu headphones are put together by the consumer, and if a part breaks, they can just send it straight back to us and we'll send out that specific part. All of the individual parts themselves are made from recycled PLA, and at the end of the part's life, it can be sent back to us, and we'll grind it down and turn it back into feedstock. We're also working on homeware projects. So Bene is an Austrian furniture manufacturer, and they were our first really big client, and they helped us to set up our second factory. So we have a small factory in London, in Hackney, and now we also have a factory in the Netherlands, which is brilliant because, of course, what we're really interested in doing is realizing this dream of distributed production.
So Milo, sorry to interrupt. Your slides aren't moving forwards.
Oh, really?
Yeah, I think we're missing some imagery.
Are we on? Does it say what we make?
No, we're still on the first page.
Okay,
there we go.
Apologies. Can you see now?
Yes, everything you said made sense without the slides, but
okay,
as you made them, it'd be nice to see them. Thank you.
Can you see?
Yeah,
this
I can
now?
see what we make.
Okay, great. Apologies. Yeah, so Bene, that's the second image there. So for them, we make accessories for their office furniture. They're really simple monomaterial objects, but they work really well. And for Bene, that was an opportunity for them to really lean into this sort of step towards a more sustainable way to manufacture goods. They're a traditional furniture maker that manufacture sort of tables for offices around the globe. And what was really interesting about this project was we were working with a UK design company, and we were able to lean into all of the other benefits of additive manufacture. So rather than having to stick with one form factor that like you would maybe have to with injection molding, because you're relying on a really expensive mold at the end, and you're kind of taking this risk with the mold manufacturer. Instead, because we were using additive, they were able to design 30 different form factors, and we can offer that with 10 different colors. So there's a huge amount of SKUs, and of course we only ever actually manufacture the parts that ever get ordered. So it gives the designers a huge amount of freedom in the design process compared to maybe a more traditional process. We're also working with Marks and Spencer's on some cladding for their stores. I realize I don't want to go into too much depth about that, but so we're working on the retail sector, which is notoriously an area where, as stores get refreshed, parts just get put in the bin. Because we are working in this case with Marks and Spencer's, who are super focused on sustainability. We're able to have collection points in their store. So as a piece of the, as a part of the merchandising products that we produce for them gets damaged or gets refreshed, they collect those back, and then they're able to send them back to us when the box is full, essentially. And then finally, the final example is Proximie, which is a medical technology company. And it was great to work with them because they are a software company who were new to the world of hardware, and we were able to work with them in the same way that they developed their software. So because we're working in digital, we were able to do things in versions, and because there's no tooling, as they were continuously changing the camera equipment which we were designing the casing for, it was no problem for us to just quickly change the design and update it in the same way they would update their apps. So we're working across a really broad spectrum of different industries. But like I say, we're really focused on this idea of circularity. So at the moment, the way in which we deliver that is through being really present in the design process. So we're really focused on design for additive manufacture, and really looking at how we can produce parts in a really efficient way. So with no post-production, really minimizing handling time for our staff. And then at the moment, we are working with partners to deliver the remanufacture of material, the re-extrusion of material, and then having that brought back to us, and we're using it again in second or third cycles. So along with sort of the existing production, so using existing production technology, Batchworks is also developing our own manufacturing technology, because we're identifying these barriers to circularity which are really stopping us scaling. It's really easy for us to have 2 sites and training operators in a very traditional way, but at the moment they have to be extremely highly skilled. Basically our operators at the moment all have engineering degrees, and what we're really working towards is building production technology which allows our operators to have what we kind of say is maybe the same level of skill as a barista. So people who really care about what they do, they're interested in making, they're interested in 3D printing, but maybe they can have it as a weekend job, or they can have it as something while they're still studying. So over the last 2 years, we've won a number of Innovate UK projects and developed our own technology that has smart part removal systems, a multi-material changer, and one of the core pieces of work we've been doing is working with a spin out from Cambridge called Matter, who have developed a AI quality control system. So our printers have a camera mounted on the nozzle, and the live feed from the camera goes through a AI algorithm which has been developed by Matter, and it recognizes when a part goes wrong. So in those early stages of a print, it can recognize that there's maybe a very small blemish on the back of a part, which would mean that it wouldn't pass QC. It can recognize that, it will stop the print, and then it will push the part off and resume. And then if that continues to happen over a number of times, there'll be an error message for our operator, and then we'll go back and review the design of the part itself. In terms of material, at the moment, we most commonly use RPLA, which is obviously the most standard material for FDM printing. We're working with 2 material suppliers in the Netherlands, who one is Reflow, who collect material from the Benelux region, so really locally to where they're producing their filament. And our factory site in the Netherlands is actually in the same location as where they're manufacturing their filament feedstock. At the moment, we are working on how many cycles we can actually take this material through before it starts to degrade. But what we can definitely say is that we have managed to take back and reprocess PLA, and it has been able to become used for a commercial material into its 2nd cycle. So we're currently selling our PLA to our customers. which has so gone through this sort of production, sale, and then collection, and then reproduction. This is really positive for us and something that we want to develop much further. In fact, this year we're going to be working with a master's student from Lancaster University who is going to be actually researching the more technical details of this, because we're really interested in degradation cycles across the material and how we can start creating blends across the material that maybe we can blend a RPLA with a 5 RPLA to bring the quality level back up to something suitable for maybe a simple product. At the moment, this is a gap in our knowledge, which we are starting to develop through further research projects. So what we're working towards with our technology is this idea that we can open up additive to a much wider audience. So through the development of our own printers and through the development of some software which is aimed to help in the design for additive manufacture process, which will be launched towards the end of the summer. So the first version of the software will be available in October. What we're really trying to do is show that this technology is something that is suitable for the development of consumer products. We're working with the design studios so that they can design a part in their studio, print it on a printer in their space, go through that development cycle locally, and we're simplifying that through the software they're developing. And then at a point where they're happy with a part, then they can instantly connect that to one of our manufacturing hubs, where we'll then take care of the larger scale manufacturing and the logistics and reverse logistics of collecting parts back and distributing them for them. Okay, I feel like I've given you a bit of a whirlwind there. So I was talking quite quickly, but yeah, so that's a sort of introduction to Batchworks and our circularity system.
Brilliant, thank you. I think you've touched on lots of things that Sherry and I introduced at the start, so that's a really brilliant rounding up for us. Thank you very much. I'm going to open up to questions from the audience. I know that Sherry's got a question, so do you want to go ahead, Sherry, while we wait for the audience?
Absolutely. Boy, I'm just super excited about what you're talking about here. I was wondering if it was Reflow that you were talking with or working with on the material side of that. So really excited to see that. They're doing some really great work. And I think you really hit on an important aspect of what AM can deliver for folks. You know, when you look at some of those consumer products, you know, too often people say, is 3D printing it the most efficient way to do it? And quite often it is not. But what it delivers for the consumer and for the retailer is this expanded choice set, right? Because you don't have to necessarily guess what consumers are going to want and then produce a ton of those. You can see more where consumer demand is and then produce that. And so, like when I talk about distributed manufacture, it's not just distributed geographically, but distributed, you know, moving it closer to demand and being able to get those additional choices. We've all had the experience of going to a shop and you look on the shelf and there's either limited choices or the one you want they're out of. And this ability to be able to provide that and provide more choices for customers, for consumers, I think is a really big aspect of what AM has to deliver that can really be leveraged, I think, in a big way.
Yeah, I mean, massively. I think that, I mean, honestly, we're finding that as long as we can have a conversation with a customer, we kind of, all of our leads end up turning into projects, because there are so many angles with AM that you can take, whether it is like speed to market or you know, low investment cost for tooling, or the number of SKUs you can offer on a product, or opportunities for recyclability. Like there's always an angle, particularly if you find a client that is willing to be sort of more flexible on business model. When you find people that are really stuck in the mud and really kind of focusing on traditional production methods, that things get a bit more difficult. But you realize that actually nobody is that stuck, because everybody realized the world is changing very quickly and we all have to adapt. So people are often very quick to see the benefits. So it's really exciting time for us. And completely, like you say, for us, yeah, working with design studios, as soon as they can actually see that they can rethink the way in which they design products, and rather than having this really, my background is industrial design, and when you learn, even up until now, the way you study is essentially you're basically doing one big de-risking exercise up to a moment where you're about to invest in tooling or production, and then at that moment you have to have this perfect product which you're betting on being a success. Whereas if you completely flip that on its head and think much more digitally in a much more flexible way, you can start thinking about, okay, we can almost do A/B testing with hardware in the same way that you do when you sell software, because people are only buying the thing that they like, and you're not having to produce hundreds of thousands of things and they sit in a warehouse and get unused. You're only ever making the specific item that gets purchased. So there's loads of benefits.
Yeah.
I think we're all preach, it's a great room to be in because everyone's excited about it.
Yeah. And I think being able to, like you said, you do this de-risking and then you have to produce a lot of these. And so if you discover there's a problem with them, your choices are just go ahead and burn through that inventory and just accept the problem, or you potentially trash, all of those parts and maybe the molds. Or if you see an enhancement, now that you've got this thing and, you're seeing it and it's getting used, the ability to implement an enhancement to it, it's a big business decision, because again, it's just like making a correction that can be very costly.
Yeah, we're seeing those examples in almost every production run we do. So we do runs of like between 1,000 to 10,000 parts, like very regularly, and we'll often. There's a good example. Recently, we were making a casing for a startup that were developing an environmental sensor for the school system in the Netherlands. And midway through their first run, so they wanted 5,000 units, we produced and delivered, the first 1,000. And they realized that there was a button that could, if it was a centimeter further to the right, it would be much easier for the students to use. And in the middle of the run, like without the production stopping at all, we were able to shift the button into the location that it needed to be shifted into. And that's just something that would never be possible with traditional production methods. Like we didn't even stop manufacturing. We just continued, and one had the button in one location, and then the next unit had it in the new location.
Wow.
That's just something you cannot even fathom with traditional production, let alone producing something and communicating with someone on the other side of the world and having to wait for emails to bounce back and forth. Like we were able to have a call and have the right product in manufacture by the end of the day.
And you can even implement that even in injection molding, for example, the fact that you could change the tooling that quickly. I know one of the things Pepsi was looking at was being able to produce specialty bottles for different events. So imagine you were going to create a specialty bottle for, a championship game or a playoff game, or, in sports, where you don't even know who's going to be in the game that much ahead of time. So you could traditionally manufacturing, you could never do that. You couldn't get the mold made fast enough. But with additive, you could either produce the part or produce the mold very quickly to be able to do those smaller run, very specialty items that just we're all kind of conditioned to know that you couldn't do. But with AM, you can do those. Those barriers are gone.
Exactly. It's just, and I think we just have this really exciting. We're in this exciting moment where it, for us, it's still a big challenge, like to convince people that this is an interesting way of doing things, and to show designers that there are this whole new set of constraints that they need to learn, because it's not easy to design for this process, particularly at the moment, because all of the design software is geared towards traditional methods. So it is a big challenge, but it's a really exciting challenge. So we're really happy to be part of it.
Brilliant. Thank you very much, Milo. I'm going to just express how impressed I am with how all our speakers have kept to time. lots of questions, and yeah, this level of precision doesn't happen in academia, which is why I do lots of work with industry. There's no huge egos dominating the whole schedule. It's fantastic. So I thought I'd just take a couple of minutes to just summarize really some of what I think we've covered today. What I did like about today was that we didn't just focus on what happens in the factory. And I think quite often a lot of thinking about manufacturing and manufacturing processes can think about just what happens in the factory. And we didn't today. We thought about the process of design, thinking in circular terms, thinking about longevity, also highlighting that AM can be used alongside other technologies. Yannick talking about his hybrid production. A nice note to remember then that we're not always just talking about AM. We thought about data, using data, how to get data, what parts of the production process you need the data about, some of the challenges around getting the data, and then how you analyze it. Lots of speakers today talked about life cycle analysis, and developing their own variations of life cycle analysis, which I should imagine is an awful lot of work. I wonder how much repetition of that kind of heavy work is going on within firms and how much knowledge sharing there could be about that. We also talked about inputs, and we by design wanted to think about materials, but I think that the speakers took us on a broader, more interesting journey to think about different types of inputs. So thinking about energy, the costs of energy, sustainability of energy, prices, differential prices, and then also about different materials and learning about different types of materials and the sources of those materials. So learning about castor beans and agriculture was a nice complement to thinking about the origin of powders and plastics polymers. I think we also thought about where the products end up, including consumer goods. And as Sherry had highlighted, sometimes these bigger markets into the consumer are where we find that broader relevance and those talking points, which I think are quite illustrative and supportive of the sector. Also, we did manage to mention skills. I thought we were going to get through a conversation about AM without thinking about skills, but we did. So thanks to Milo for highlighting that. I think that's probably something that's going to come up in day 2 as well. So I think we spent a lot of time today thinking about how AM can help us to do more with less, particularly in terms of resources. So I was really interested in all the speakers' contributions and thank them very much for their contribution. As a taster for day 2, which is on the 19th of June, we'll be looking at spare and legacy parts and value chain sustainability. So we will have talks from, amongst others, Speed 3D, John Deere, Rolls-Royce and 3T Additive, with a couple more to be confirmed. So we hope very much to see you there. Sherry, any sign off from you?
Hey, this was a great day. All the speakers were just tremendous. I'm so impressed with what they were able to communicate in such a small amount of time. Really just tremendous. And thank you to all the people who joined in and provided information and questions. Just really tremendous event. I'm really looking forward to next week. And thank you for the team that Jennifer and I worked with in putting this together. Really did a great job. And yeah, this was great. Really looking forward to next week.
Brilliant. Thank you. So thank you all for coming, and we do hope to see you next week. Any feedback that you may have is more than welcome. And yeah, keep thinking about how we might be able to continue this and support each other as we move towards sustainable futures.